Hello everyone, happy Wednesday. Thanks for tuning in to another special live stream. My name is, press the wrong button. My name is Patrick Hess. I'm the Planetarium Specialist at Union Station. And we've been doing some of these little fun live streams from home if you're tuning in for the first time. We're streaming on Mondays, Wednesdays, and Fridays at 6 p.m. And if you're coming back, thanks for joining us yet again. Hopefully we're keeping our content fresh for all of you to tune back in and learn something new. Just to recap what our schedule is like. On Mondays, we're doing a star tour. That's our What's Up tour for the week, where I take a little tour showing you what you'll be seeing in our night sky throughout the week. Then on Wednesdays, our streams will be a special deep dive looking into different topics, all about astronomy and space exploration. So far, we've covered topics like our solar system, as well as stellar evolution. And today's deep dive will be all about the Messier catalog, which we will dive into in just a moment. And then on Fridays are our special Fan Friday, where we dedicate a whole show just to answering your fan questions live on the air. You're always welcome to throw in fan questions and questions about space and science all into the comments at Union Station on our Facebook page, or if you're watching from the Science City Facebook page or the Planetarium Facebook page, feel free to comment there as well. On Mondays, we'll answer a few of those questions. Wednesdays, we may not have as much time to answer those questions just because we have a lot of content to cover, but we always write down questions we miss, and we'll definitely be bringing all those questions in on Friday, answering those, and then answering all of your other questions popping in. So Fridays are a lot of fun. Because I get to interact with you directly. But Wednesdays, today is a special day where we get to take a deep dive into a special topic. Before we do, I wanted to give one last thank you to our Union Station members, all 10,000 of you. Without your support, it wouldn't be possible to do these awesome and unique programs and events and things like this. And hopefully you guys are enjoying all the things that we've been bringing you online while we've been staying home, and we cannot wait to see you all back at Union Station when we reopen. But in the meantime, thank you again for your continued support. All right, let's jump into today's deep dive topic. It always feels like I don't have a lot of content to cover, but as we figured out last week, sometimes I underestimate all the stuff, so we're going to jump right in and dive straight into it. So let's learn about my friend Charles Messier. Charles Messier was one of the most famous astronomers in history. He was born on the 26th of June in 1730 in northern France. He was the 10th of 12 children. So you can just imagine what that childhood must have been like. He became interested in astronomy at a very early age during a very famous comet in 1744 that some people nicknamed the Great Six-Tailed Comet. There's an artistic depiction of what that may have looked like. So when he was just 14 years old, he was awed by this celestial event, and that sort of initiated his interest in astronomy, and he started learning more about it and studying it. Then when he turned 21, he started working for an astronomer in the French Navy. And while he was doing this, he started his personal catalog of objects and observations. Some other things: in 1764, he was made a Fellow of the Royal Society, and in 1770, he was elected to the French Academy of Sciences. So he was a pretty big deal even back in his own day. But he was most famous for his famous Messier catalog. Now, Charles Messier was actually interested in comets. He was a self-professed comet hunter. He actually discovered 13 comets during his life. But as he was looking for comets, which are objects that are moving slowly throughout the evenings, and so they'll be in different places each night, he started to find other objects that on first glance looked like comets, but as he looked more closely at them, he saw they weren't moving, and so he kind of got frustrated by them, and he became so annoyed by these objects that he started writing them down in this catalog so he could ignore them during his search for comets. So it's a bit ironic that his catalog was one of the first and is still one of the most famous catalogs of amazing and beautiful deep space objects. And really, it was a catalog of things that he himself didn't actually care about that much. So just kind of a funny story, but we still thank him for his service. Now, since he was observing in the Northern Hemisphere, most of the objects he found were only visible in sort of the northern parts of the world. So there are a lot of other objects that we've discovered since then that may be brighter or cooler to some people than Messier's objects, but these were just the objects he discovered. He first published this list in 1774, and at that time the list had 45 objects, but by 1780 it had grown to over 80, and then his final version in 1781 contained 103 objects. But throughout the 1800s and 1900s, other scientists pored over his notes and actually found found exactly 7 more objects that he had actually observed but didn't end up writing down. So today the catalog contains 110 deep space objects. Now, these objects come in a variety of categories. 27 of them are open star clusters. 29 of them are globular star clusters. We'll talk about the difference between those today. 6 of them are diffuse nebulas. 4 of them are planetary nebulas. 40 are galaxies, and of those galaxies, 24 of them are spiral. 8 of them are elliptical, 4 of them are barred spiral galaxies, like the Milky Way, and 4 of them are lenticular galaxies. And there are some other random objects thrown in. There's a supernova remnant, there's a Milky Way patch, sort of a cool section of the Milky Way. There is one double star, which is a bit random that he put it in his catalog, because the 2 stars in this system are actually not related to each other. I believe that is 40. But anyway, he just decided that was interesting enough that he wrote it down. And then one of them is actually an asterism, so just a group of stars. So these Messier objects are pretty popular. There are a lot of other catalogs of objects, of course, but this catalog is pretty small and has some of the most famous and most beautiful objects. So it's often referenced when we're talking about deep space objects and some of our favorite things in space. When you're talking about a Messier object, you call it M followed by its number. So M42, for example, is the Orion Nebula. We'll be looking at that today. But that is the Messier catalog. Some astronomers and amateur astronomers do these events called Messier marathons, where they try to see as many Messier objects in one night as possible. You can actually see them all in one night if you're in the right place, if you're at about 25 degrees north latitude, and for a brief period of time in sort of mid-March to early April. You can see all 110 of these objects in one night if you're very dedicated, and if the weather's nice. And here's just a map sort of on our celestial sphere of these objects. And this celestial sphere I've shown off before in this sort of globe right here. This is laying out all the objects in space in sort of a flat sphere. Of course, we know different things in space are different distances from one another, but this map you're seeing on your screen is sort of just a 2-dimensional translation of this same thing. And so you can imagine how if you're in the northern hemisphere, you wouldn't be able to see a certain section of things down here on the bottom of the globe, since they're sort of obscured by the curve of the Earth. So before we jump into my top 5, and this is going to be a list of just my personal favorites. These aren't going to be in any particular order, and they are, some of them are special in my opinion, and probably in the opinion of many others, but these are just my personal 5 favorites. So if there are any Messier heads out there in the audience, I'm sorry if I don't bring up your favorite Messier object. But I do have a couple honorable mentions I just want to talk about briefly. We're not going to dive into much depth on. So the first honorable mention I'll bring up, we'll just go in numerical order, is Messier object 45, is the Pleiades star cluster. I've talked about this a couple times during both our star tours and our stellar evolution discussion last Wednesday. This star cluster can be visible with the naked eye. It's near the Taurus constellation. It was visible in the early spring and late winter. You might not be able to see it. It's setting pretty early in the evenings right now. But I do point it out during my star tours, which you can rewatch. If you missed Monday's stream, you can find that on the Union Station Facebook page, a recording of that. But the Pleiades star cluster is an open star cluster. Open star clusters are relatively young. They contain about a couple thousand stars that are all around the same age and are all born from the same nebula. We can see the leftovers of that nebula reflecting the light from these young stars. So this is the leftover clouds of gas that aren't hot enough to emit their own light, but do reflect the light from the younger stars in the Pleiades cluster. Another honorable mention I'll bring up real quick is M57, the Ring Nebula. This nebula is a planetary nebula. Has nothing to do with planets. This is one of the ways that stars die. I discussed this in more depth last Wednesday, so feel free to rewatch that stream if you want to learn more about that. But the Ring Nebula is a stellar remnant. It's the leftovers of a dead star. Now this star was an average-sized star, and so it didn't explode or anything exciting like that. It simply spread its layers out into space. It died about 6,000 years ago, so this object is about 6,000 years old, you would say. The different colors are different types of gas that were part of that star, with a white dwarf stellar remnant at the center. This is the leftovers of the core of the dead star. But this object is visible through a moderately powered telescope in the summer skies. This is near the constellation Lyra. And then my last honorable mention is a kind of a fun one. It's Messier Object 104, which is nicknamed the Sombrero Galaxy, for sort of good reason. This galaxy we are looking at sort of edge on, and it has a really prominent dark lane of dust around it, and it also has a very bright nucleus of stars, so it kind of has this sort of sombrero-shaped form, which is kind of funny. About 30% the size of the Milky Way, and it is visible through amateur telescopes. And we can actually see it. This is a later thing. Let's go to the Sombrero Galaxy and look at it in 3D. This program is Space Engine. We've mentioned this before, and we can put a link in the comments to where you can find it. We are not affiliated with this particular program, but you can purchase it if you'd like to explore the universe in 3D. But anyway, here is the Sombrero Galaxy in 3 dimensions. You can see from the top down, it looks like a pretty typical galaxy, but since our angle is looking at it from the side, it's got that really nice sort of flat disk shape. All right, let's head back to our main list of my top 5 Messier objects. And we're going to go in order of Messier catalog numbers, so these aren't in order of my personal favorites, but that just makes it easy. And we're going to start with, Messier object number 1, the Crab Nebula. The Crab Nebula is a supernova remnant. We actually did visit this last Wednesday as well. But this is one of my favorites because it ties in with history, actually. Supernovas are pretty extreme, and most of them, or many of them, have been visible to the naked eye in the skies and have been recorded by historians. There are a number of supernovas. Only 8 supernovas in our Milky Way have actually been identified based on recorded and written history and testimony. So this is one of them. We've actually been able to pinpoint which supernova it was. And this particular supernova was recorded on July 4th in the year 1054. So this supernova happened about 1,000 years ago. It was recorded first by Chinese astronomers. They nicknamed it a guest star in the constellation Taurus, where it appears. At the time, it was 4 times brighter than Venus at her brightest. It was visible in the daylight for 23 days. So in the middle of the day, you would see basically another star in the daytime sky. And it actually stayed visible at nighttime for about 2 years, visible to the naked eye. There have been other references found in Japanese historical records and documents from the Arab world. This was actually probably recorded by Anasazi Native American artists, and we've actually... here's a photo of some petroglyphs found in New Mexico that, based on their age and the content, were likely depictions of this supernova. Basically, sort of based on the proximity of the crescent moon, which was visible at that time, to that supernova, and the fact that it would have only been visible in North America, in Western North America at that time, it makes a lot of sense that this petroglyph is depicting that supernova. So pretty cool that we've recorded these things through history, and we can see them today through these deep space objects. This particular supernova remnant, or nebula, we call it, is visible through binoculars, assuming you have favorable conditions. So you don't even need a telescope to see it. It's about 6,500 light years away from us, and it's about 10 light years across. And it is actually expanding. So this is a supernova remnant. So when this star died, it ejected its elements in a violent fashion. And this nebula is still expanding to this day. It's expanding at a rate of about 1,000 miles per second, which is about 0.5% the speed of light. We call that relativistic speeds. And it's expanding so quickly that we've been able to observe it over time, and we can actually see that expansion. So this is an animation using real photographs taken of the Crab Nebula over the course of about a decade. We can actually observe it expanding in basically real time. I mean, it blows my mind to see animations like this and see this nebula, which you'd think is this static thing in space, is actually moving in the scale of our own lifetime. At the center of this nebula is a pulsar, and you can actually see that pulsar messing with the the gas here at the center. You can see this sort of disk of material sort of jetting around. This pulsar is the leftovers of the core of the supernova. It's a neutron star, about the size or about the mass of the sun, but only the size of a small town. So all that mass of our sun crammed into that small of a place. That's how dense neutron stars are. And this neutron star rotates about once or 30 times each second. We actually can use pulsars to measure stellar distances and things like that because they rotate at measurable frequencies like that, sort of like a lighthouse spinning around. And that's what's causing those ripples, sort of center of this animation. Again, it's not an animation. This is video. You could actually say of Crab Nebula. So that is Messier number 1. Is the first in his catalog. Let's continue on to the next Messier object. One of my favorites. This is Messier. So here are some other non-visible wavelengths of the Crab Nebula, and we can see this is a much better picture of the pulsar at the center of the nebula, sort of ejecting those pillars of electromagnetic radiation from the poles there. All right, so we are going to continue on to Messier number 16, is the Eagle Nebula. The Eagle Nebula is an emission nebula. It is a active star-forming region, and it's about 5,700 light years away, and it contains about 8,000 stars. They're estimated to be a couple million years old, which is pretty young for a star. Stars live for billions of years. This is one of my favorites because it has a lot going on. There are a lot of different regions of this nebula, some of them fairly famous, and some of them have been photographed for decades. Yeah, let's take a look at some of those. So one of the most famous regions is the Pillars of Creation. This photograph was captured by the Hubble Space Telescope soon after its launch around 1995. The Hubble Space Telescope is one of our best eyes on the universe. A lot of the pictures I'll be showing you here are from the Hubble Space Telescope. I've got a tiny little figure of the Hubble Space Telescope. My boss told me to use more visual aids, so we're resorting to Legos. So this person here, it's not really focusing, but this is Nancy Roman, who was a NASA executive, and a lot of people say is sort of the mother of the Hubble Space Telescope. It was a lot of her vision and leadership that was instrumental in getting this telescope launched. But this telescope has been our best eyes on the universe for the past almost 3 decades, and it is the best outside of our atmosphere observatory. So far, there are other space telescope projects that are in the works, like the James Webb Space Telescope, but they haven't launched yet. Hopefully, they'll be launching. But let's go back to our Messier tour here. So this part of the Eagle Nebula, like I said, is nicknamed the Pillars of Creation, and this picture was taken in 1995. 25 years after that, the Hubble actually took another picture of it after some of its recent upgrades, and got pictures of it in even greater detail. But these pillars are light years in length, and they're dense regions of gas, mostly hydrogen, that are forming new stars. At the tips of these pillars are stars that have just been ignited, which are now boiling this leftover gas away. We can see the gas sort of flying outwards there. But just one of the most beautiful regions in space, and a very famous photograph, which you've probably seen over the years. There's another region called the Black Pillar, which is 10 light years tall, and it's a similarly evaporating pillar of gas as new stars are formed inside of it. Just one of the most photographed deep space objects, and since it is such a wide nebula region, it just has a lot of cool, different, smaller parts to it. That's why I like it so much. M16, the Eagle Nebula. Let's move on to M22, the Sagittarius Globular Cluster. It's official. It doesn't really have an official name. It's just called the M22 Globular Cluster, but it is in the constellation Sagittarius, so we'll just call it the Sagittarius Globular Cluster. So we talked about open star clusters, which can contain a couple thousand stars and are all the stars are born from the same nebula. But globular clusters are different. They contain stars of varying ages. So these stars were not all born at the same time. And they're all bound together by gravity, and they contain tens of thousands of stars, sometimes even millions of stars. The main theory for how globular clusters are formed is that they're likely the remnants of the cores of smaller galaxies that were actually absorbed by the Milky Way galaxy during the beginning of our universe. These globular clusters contain stars that are tens of billions of years old, and this particular globular cluster is no different. It's 11,000 light years away, so a bit farther away, and it's closer to the center of the Milky Way galaxy. It contains about 83,000 stars that we haven't been able to count so far. Most of them are very old. These stars are about 12 billion years old. Bear in mind that our measured age of the universe is 13.8 billion years old, so this globular cluster has been around nearly since the beginning of our universe. And we've also found 2 black holes inside of this globular cluster, and we think there are about between 5 and 100 black holes in this cluster as well. One kind of fun fact about this globular cluster is that because it's sort of near the center of the Milky Way and sort of in that direction towards the constellation Sagittarius, it is actually really useful in an astronomy technique called gravitational microlensing. So what scientists do is they point things like the Hubble Space Telescope at this globular cluster, and then they look at stars behind it. So they look at a bright star near the center of the Milky Way behind it. And what they're looking for is they're looking for gravitational lensing. So since this cluster is very dense, there are lots and lots of objects, many, many stars, and likely other darker objects that aren't emitting light, like brown dwarfs or maybe even planets. And as these objects pass in front of these distant bright stars, they cause gravitational lensing. The gravity from these massive objects bends the starlight from this background star and temporarily makes it brighter. And scientists have actually done this. About a decade ago, they started this experimentation, and they've been able to use this technique to discover these darker objects that were previously unseen by just observing their gravitational lensing. As far as where this is visible, let's go back to Space Engine here. If we go back to Earth for just a moment, you can find this. Oh, I turned planets off. There we go. You can find this object towards an asterism called the Teapot, which is in Sagittarius. This is visible in the summertime in the southern sky, and let's see if I can find it in 3D space. I'm not used to looking for things in this direction. It should be near the galactic center, which is right over here. Let's see how good my stargazing is. We might be kind of upside down. That might be why it's hard to find. I guess I could cheat. Burn constellations. You guys won't mind. All right. There he is. There it is. Okay. Yes. So it's in an asterism right around here. In fact, we can just this M22. All right. So there it is. So it is visible. Probably not with the naked eye, but through a pair of binoculars and definitely an amateur telescope. And well, why don't we just fly to it? See it close. Here it is. So again, scientists think that these globular clusters are the leftovers of other galaxies that we have collided with and absorbed. And this actually brings us to the next stop on our little tour of the Messier Catalogue, one of my other favorite Messier objects. And this one is visible to the naked eye. It is Messier object number 31, the Andromeda Galaxy. The Andromeda Galaxy is a barred spiral galaxy, just like our Milky Way galaxy. This one is pretty far away from us, 2.5 million light years away, but it is the closest major galaxy to the Milky Way, and it is the biggest galaxy in our local group of galaxies. This galaxy actually contains a couple other galaxies, we call them satellite galaxies. This is Messier object number 32, and this one is Messier 110. So there are actually 2 more Messier objects in this Messier object. The Milky Way has satellite galaxies called the Magellanic clouds, the small and large Magellanic clouds. These galaxies may turn into globular clusters after they're completely absorbed by Andromeda. So Andromeda is visible in the fall and winter near the constellation Andromeda, and it is fairly bright. With the naked eye, it'll appear as sort of a dim smudge near Andromeda, but if it were brighter and our eyes were better, it would actually occupy a space 6 times as wide as the moon. So its angular diameter, how wide of a space it takes up in the night sky, is 6 times the diameter of the moon. So if it were brighter, this was what it would look like in the sky. I mean, that's kind of crazy. You think of these things as being super distant and very tiny. You need telescopes to see them, but Andromeda is actually already kind of pretty close to us. I mean, imagine seeing this next to the moon in the night sky. Crazy. So Andromeda is twice as big as the Milky Way. It likely contains over 1 trillion stars, and it should be about twice the mass of the Milky Way as well. It was first observed and recorded by a Persian astronomer named Abd al-Rahman al-Sufi in the year 964, and he nicknamed it a nebulous smear. So whenever you look up in the sky towards the constellation of Andromeda, just look for a smear in the sky. Later star charts labeled it as a little cloud, and it was first photographed in 1899 by somebody named Isaac Roberts. And here is that picture. This photograph was taken in 1899 of the Andromeda Galaxy. Pretty crazy. So the most special thing about the Andromeda Galaxy, in my opinion, is that it is on the move. It is actually traveling towards the Milky Way Galaxy. It's heading for us at a leisurely pace of 68 miles per second, and in about 4 billion years, our two galaxies will collide. So this simulation is going to show us what this collision will look like. Now, most stars in both of our galaxies are so far away from one another that there is very little chance of any two stars actually colliding or even interacting with each other's solar systems when this happens. So, this won't really affect us besides giving us an amazing light show and changing what our night sky looks like. Also, like I said, this event is not going to happen, as you can see, for another 4 billion years, and I don't know about y'all, but I've got other places to be in 4 billion years. But as you can see, these two galaxies will collide, and eventually they will merge to form a brand new super galaxy. And as they get older, their color will change as well. Most of the stars in these two galaxies are relatively young, so that's why they're mostly bluish in color, but over time they will yellow as they age, and then our galaxies will form an elliptical galaxy, which is unstructured massive stars, and it'll look something like this. All right, we're making pretty good time here. And we are going to jump in to our... Oh, before we jump into our final object, since we're doing pretty well on time, I'm noticing we're getting a lot of great questions, so let's see if I can answer some of those. Dana's asking about when's the best time to view planets in our evening sky. Be sure to tune in for our Monday star tours, because I talk a lot more about planetary observations. But to briefly answer that question, you'll be able to see Mars, Jupiter, and Saturn in the early morning sky right now, but as the year goes on, you'll be able to see them in the earlier evening sky. Brian asked a question about the Crab Nebula, and he asked, he was saying that these objects are really beautiful, and what gives them their vibrant colors. So let's return to the Crab Nebula, and let's talk a little bit about that. So the Crab Nebula is a supernova remnant. So all of these different colors are mostly coming from heavy elements that are created during supernova explosions and implosions. So when a supernova collapses, all that force compresses its core, which creates heavy elements. In fact, pretty much the majority of the elements in our universe were created, or have been around either since the beginning of our universe, are created inside of stars as they're burning, or are created in supernova explosions. So these different colors are different wavelengths of light emitted by these forms of light, or by these different elements. That's what we're looking at in these supernova remnants. Let me talk a little bit more there's one more Messier object, and I'll talk more about the colors of objects in that, because it's going to tell us a little bit more about that object itself. But that's a great question, Brian. In fact, you're jumping the gun a little bit. I was planning on talking about that already, so good question. Let's see real quick. David is asking, which Messiers do I suggest to start for families that are new to astronomy? That's a great question. And these objects that I'm showing you are all visible through moderately powered telescopes or even binoculars. So these are great starts. The Pleiades cluster for sure is one of those that I showed you before during those honorable mentions. And the Ring Nebula is a great sort of intermediate, like a good challenge, because that one's a little bit smaller and a little bit farther away. So once you're comfortable with all the other ones I've shown, then you'll be able to maybe try your hand at finding that one. Katie's asking about supernovas and black holes. Now, this particular supernova that created the Crab Nebula ended up with a neutron star. But for more massive stars, if a star was even bigger than the supernova that created the Crab Nebula, then it may collapse to form a black hole. Now, the physics of how and why that happens, I discussed last Wednesday during our stream about stellar evolution. So Katie, if you want to know more about that, I definitely recommend you check out last Wednesday's stream, because I go in deep depth about black holes and how they're formed and how they are related to supernovas. All right. Okay, we're going to jump back into the last Messier object I'm going to show you. And while I'm loading it up, we got a couple people chiming in. Kristen saying hi from Ottawa, as well as Gio from Japan. Thanks for tuning in. Awesome, and really appreciate all your feedback. And David as well. Thanks for checking these streams out. I'm glad you guys are enjoying them, and shout out to your kids as well. Hope these guys are learning something new from all these. All right, so let's jump back in. Oh, Kristen's asking on Friday about if we can learn about the Milky Way galaxy. Sure, I'll write that one down, and we will talk a little bit more about the Milky Way in depth on Friday. Absolutely. All right, so the last Messier object, and my personal favorite Messier object, is Messier number 42, the Orion Nebula. The Orion Nebula is one of the brightest nebulas. It's actually visible to the naked eye. It is in the constellation of Orion, as you might guess. In fact, let's go back to Earth, and I can show you exactly where to find it. It is visible to the naked eye, and it is part of the Orion constellation. So let me rotate ourselves a little bit to give you a better orientation here. So we can see Orion behind Earth right here. It might be hard to see my cursor, but 4 stars outlining the 3 stars of Orion's belt. Now below Orion's belt, you'll see a smaller group of 3 dimmer stars. Some people call this his dagger or his sword hilt. And the center star of that region is not a star at all, but it is the Orion Nebula. And select it here. Oop. Oh, may not let me select. There we go. There it is. So let's fly over to the Orion. This is how it's simulated in our space program here, Space Engine. We can see it in 3D volumetrics here, but we want to go back to our Hubble Space Telescope photo that looks even cooler. The Orion Nebula. This nebula is a star-forming region about 1,400 light years away. It's 42 light years across. It is gigantic. It is the closest massive star-forming region to our planet. Now, this photograph was taken by the Hubble Space Telescope very recently, but Messier himself tried his hand at artistically showing this nebula, and this is the drawing that he came up with back in the 1700s. Not too bad, I would say. Now, he observed a group of 4 stars at the center of this nebula called the trapezium, and these stars are a little cluster, a little open star cluster that was born very, very recently. I think I've got, yep, there's an even closer picture of the trapezium. The trapezium is visible through binoculars or a telescope, and this is another great sort of intermediate challenge. Another intermediate challenge after you've gotten some practice at finding planets and other deep space objects. So try to find the trapezium would be my suggestion for you. But these stars were discovered by Galileo, actually, in the 1600s. And these stars are only about 300,000 years old, which is very young for a star. Again, stars live for billions of years. Now, some scientists have done velocity calculations in these stars, which have sort of suggested that there may be a black hole in this cluster as well, but we're not totally sure. Let's take a look at those colors again. Now, as Brian was asking about the colors, I mean, this doesn't even look real, right? It looks like a painting. But this is actually visible light from the Orion Nebula. The blue-violet coloration is reflected light. So these part of the nebulas are actually reflecting the young light from the massive stars that are just being born at the center. That's giving them their sort of bluish color, as these stars are extremely, extremely hot. And then the reddish color is the nebula itself emitting radiation. And this radiation is mostly coming from hydrogen in those star-forming regions. Now, one mystery is the green color. Now, this green color is sometimes, some people claim, visible to the naked eye through telescopes. And the green color has been stumping astronomers for most of the 20th century, because when comparing this particular color to other spectral classifications of elements we've found, we couldn't really match it with anything. And actually, for a lot of the 20th century, scientists thought that it was actually coming from an undiscovered element, which they nicknamed nebelium, or nebulium. But that is not the case, and recently it was actually confirmed that this green color is actually probably caused by low probability electron transitions in ionized oxygen. Now, that sounds like something I just made up, but this effect is actually what causes phosphorescent glow-in-the-dark materials. So if you have glow-in-the-dark stars on your ceiling, that same chemical process is what is creating the green color inside the Orion Nebula. So again, way to think ahead, Brian, thinking about that question. So Orion is forming new stars, and there are thousands of stars in this nebula that have been born. But it's not only creating new stars, it's also creating new solar systems. So inside of the Orion Nebula, we have found these little features that we call proplyds, or protoplanetary disks. So these stars are either in the process of igniting stellar fusion, or they have very recently done so. And we can actually see through our telescopic observations the clouds of gas and debris floating around these new stars that may someday form planets. So if there was an alien looking at the sun after it was just formed 4 billion years ago, they might see a similar protoplanetary disk that would eventually end up as our solar system. So it's just, I just really love this deep space object. Not only is it beautiful, but it's just, looking at it, we can see sort of billions of years of star formation, and we really get a sense of sort of our own history. And the last thing I'll leave you with is a little animation that NASA scientists have produced using advanced imagery from Hubble and other space telescopes to simulate what it would be like to actually fly into the Orion Nebula. So these nebulas, this gas and dust is left over from, there goes my lighting. This gas and dust is left over from other stars that died and expelled their elements billions of years ago. I don't know why it suddenly turned yellow. So this is leftover gas and dust from ancient stars. And over billions of years, the gas and dust gets pulled together by gravity, eventually forming stars. And like I said, sometimes this gas and dust is left over floating around, and that gas and dust will occasionally form planetary systems as well. So our star, the sun, all the elements inside of it were created by another star that died a long time ago and expelled its elements back out into space. All of the planets in our solar system were created by that same process. Jupiter and Saturn, the gas giant planets, were trying to become stars, but they never quite got big enough. They ended up as gaseous planets. And then the smaller rocky planets like Earth came from that same interstellar medium. So all the elements that form our planet were also created by that distant star. So in turn, humans are connected to this system as well. All the elements in the human body, everything that you are made out of, was also forged in the core of an ancient star that died billions of years ago. So in a very real and scientific sense, we're all made of stardust. And that's, I think, why I love the Orion Nebula the most, is because when most people look up at the night sky, they feel small. But when I look up at the night sky, and especially when I look at the Orion Nebula, I feel big. I feel connected to the universe in a very real and scientific way, because we're made of the same stuff that the whole universe is made of. So really, we're all star stuff. And that is the sentiment that I will leave you with at the end of this special tour of my favorite Messier objects in the Messier Catalogue that Charles Messier created in the 1700s. Thank you all so much again for tuning in. This has been Patrick Hess, your planetarium specialist. And we've got a couple other questions I'm noticing, but unfortunately we don't have time to answer them today. But don't worry, I'll be writing those down. And on Friday, we will be diving into those first thing. And if you have any other questions you'd like to ask or think of any in the meantime, be sure to tune in on Friday, where we will be answering all of your questions live, and I'll be talking to all of you as we explore the universe together. For now, though, I hope you guys have a great rest of your Wednesday evening, and we'll see you on Friday. Bye, everyone.